What if I told you there's a tiny hidden world beyond Neptune, and something just woke up on its surface? Stay with me, because by the end, you'll feel like you've actually visited a dwarf planet in the outer system. In this video, you'll discover what a dwarf planet really is, how it's different from a normal planet, and you'll take a guided tour of one frozen world far from the sun, step by step, until its mysteries make sense. Imagine standing on ice so cold metal would shatter under a sun that's just a bright star. That's daily life on a dwarf planet in the outer system, tiny, distant, and easy to ignore, until you see how strange it really is. So first, what makes a dwarf planet? Dwarf planet, it orbits the sun. It's mostly round, but it's too small to clear other stuff from its orbit. Think of it as a mini-world in a crowded lane of space traffic. Regular planets, like the big gas giants, have cleaned their orbits over time. Dwarf planets haven't. Their neighborhoods are still full of icy rocks and debris, like living in a city street always packed with drifting traffic. Now let's fly outward, past Mars, past Jupiter, past the giant planets, until we reach the Kuiper Belt, a huge ring of icy bodies. Out here, our chosen dwarf planet quietly circles the sun in deep, slow motion. Our dwarf planet is small, maybe only a fraction of Earth's moon. Its gravity is weak, its surface is frozen, but it's still a full world, with its own mountains, plains, and maybe even a hidden ocean beneath the ice. Look at its orbit, huge and stretched, taking hundreds of years to go around the sun once. Seasons last for decades. A year there is longer than several human lifetimes, making each orbit a rare, slow cosmic heartbeat. On the surface, the sun looks like a small, intense dot. Daylight is dim, like permanent twilight. If you stood there, your shadow would be faint and the sky would feel huge, full of cold, distant points of light. The ground is made of frozen water, frozen methane, maybe frozen nitrogen, like a mix of dirty ice and frost. Over millions of years, this frozen crust can crack, sink, or rise, slowly reshaping the landscape. Because it's so small, this dwarf planet can't hold a thick atmosphere. Any gas that escapes from its surface tends to drift off into space. Still, thin hazes may appear when sunlight warms frozen gases just enough to sublimate. Sometimes, when it's closer to the sun in its long orbit, frozen gases can burst out as geysers or plumes. They shoot material into space, then it gently falls back, painting bright patches or streaks on the surface. These eruptions can slowly build smooth plains or erase old craters. Over time, the world's face changes. What looked ancient and battered can become younger and smoother, like nature slowly ironing out the wrinkles. Now think about impacts. In the Kuiper Belt, collisions still happen. When a rock slams into our dwarf planet, it carves a new crater, throws out icy debris, and maybe exposes fresher, brighter ice from deeper layers. Some dwarf planets even have rings of debris or small companions. Our world might have a tiny moon, locked in a slow dance, both bodies tugging on each other and subtly stretching their insides with tidal forces. Those tidal forces can generate heat deep inside despite the cold outside. That heat might keep parts of an underground ocean liquid, turning this frozen rock into a possible hiding place for chemistry, or even simple life. If there's an ocean, imagine dark water beneath kilometers of ice, warmed only by slow squeezing and decay of radioactive elements. No sunlight, just chemical energy and quiet, alien conditions that could last for billions of years. We haven't visited many of these worlds yet. Probes that crossed the outer system showed us how complex they can be. Mountains of ice, smooth plains, strange colors, all on bodies once thought to be boring frozen leftovers. Our dwarf planet orbits in a region packed with cousins, other icy bodies of similar size. Some are redder, some brighter, some darker. Together they form a kind of third zone of the solar system, after the rocky and giant planets. Studying them helps us rewind time. These objects are like frozen archives from the early solar system. Their compositions and orbits tell us how planets migrated, collided, and grew when everything was still chaotic. But why should you care about a tiny world you'll never visit? Because it stretches our idea of what a world is. It shows that even far from the sun, in the deep cold, nature builds complex, active places. And here's the twist. As telescopes get better, we keep finding more dwarf planets. The outer system is not empty, it's crowded. Each new discovery adds another piece to the puzzle of how our cosmic neighborhood formed. One day we may send dedicated missions to orbit or even land on these worlds. Robots could drill into the ice, sniff the surface, and map every hill and valley, turning guesses into detailed global maps. For now, we explore with light, by watching how the dwarf planet reflects sunlight and how it blocks starlight when it passes in front. We can measure its size, atmosphere hints, and even detect thin rings or hidden moons. Every orbit it completes is like a slow chapter in a much longer story. Our entire space age is just a tiny fraction of one of its years. We are watching only the opening pages of a saga that lasts centuries. So when you hear the term dwarf planet, don't think less important, think different kind of world. Small, yes, but able to have oceans, geology, seasons, and maybe chemistry on the edge of what we call habitable. You've just taken a mental trip to a dwarf planet in the outer system, from its path around the sun, to its frozen crust, to a possible hidden ocean. But there's one more step that involves you directly. Next time you look up at the night sky, remember, beyond the last bright planet far in the cold dark, little worlds are circling in silence. They don't notice us, but by studying them, we understand our own planet a little better.